Deviation, Rapasa, and Steris, who are leading today's session. Without them, we would not be able to run as many events as we do, and so we do appreciate their support. And we'd like to thank you for your support for joining this session too. So before we start, maybe I could introduce Richard, our speaker for this afternoon, Technical Service Manager, Life Sciences, Formulated Chemistries, Steris Corporation. Based in Singapore, Richard has been providing technical support and training to customers related to contamination control for clean rooms, including disinfectant validation, as well as cleaning and cleaning validation for product contact surfaces. He is also a frequent industry speaker at industry events, including ISPE and PADA, and has written articles and book chapters. Before joining Steris, he's had 16 years of manufacturing, validation, and consultancy experience working in various biotech and medical device companies. Richard also is joined by several colleagues from Steris, who are also on with us today. So if you have any questions or any concerns, please do raise them and make the most of this opportunity. So without further ado, let me hand over to Richard, and I wish you all a fruitful and enjoyable session.
Okay, thanks Linda for the introduction. So good afternoon, good evening everyone. So welcome to this webinar session on points to consider for disinfectant efficacy studies. Before I begin, I would like to take this opportunity to thank ISP Singapore affiliates for organizing this webinar and also giving us this opportunity to share our knowledge on this topic with the industry participants. So I hope every one of you will gain something from this webinar. Okay, let me set up my slide. Okay, hope everyone can see my slides. Okay, so today's agenda basically will touch on the regulatory guidance and also the guidance documents for conducting disinfectant efficacy studies. That means what are the regulations concerning these efficacy studies, and also the methods for conducting the coupon studies. And also we'll move on to consider what are the important points to consider before you perform any disinfectant efficacy studies. So what are the things to take note of, and what are the things that you need to consider so as to ensure a successful outcome for your efficacy studies. Lastly, there are some common challenges during the efficacy studies. So we will look at some of these challenges and how we can overcome these challenges. So as Linda mentioned, there are 4 poll questions during the presentations. So don't worry, these are not quiz questions. This is just questions to get your feedback. And so when you see the questions, you will just need to put in an answer based on your understanding of the questions. So before I begin the presentation, so this is poll question number 1. Christina, over to you.
Yeah, okay, give me a second. Okay, I think everyone can go ahead now and can answer. So I can see how many have answered. That's very fast. 50% answered already. 75%. 85. Almost there. 88%. Okay, so we have 93%. So I'm going to end the polling.
Okay.
Here are the results.
So interesting results. So this question is a little bit tricky. So I will tell you the answers after the next slides. Okay. Okay, so before we go into the disinfectant validation studies by the end users, so I would like to spend a few minutes on understanding, let everybody understand the disinfectant regulations that is governing the vendors. So it will be good if the end users can understand what are the test methods, what are the efficacy studies that was performed by the vendors to support the label claims. So basically, this relates to the laws governing the germicidal products registration per country. So typically, each country, they have their own laws governing the germicidal products in each of the countries. So for example, in the US, so in the US, these germicidal products is regulated under the FIFRA. So FIFRA is basically the Federal Insecticide, Fungicide, and Rodenticide Act under the pesticide laws. So this FIFRA is administered by EPA. So basically, this means that all the vendors, the manufacturers of chemical disinfectants, and also those manufacturers who want to sell the disinfectants in the US will need to basically abide by the EPA rules and regulations. So this will come under the EPA. And for EU, so EU, they have their own disinfectant, the germicidal products regulations. It's called the biocidal products regulation. So it's different regulations altogether. So in this context, we look at the US. So US is basically under the EPA. So this means that all the chemical disinfectants is under EPA and not under FDA or EMA. So, but having said that, there are exceptions. So for chemical disinfectants, if you are using the chemical disinfectants as a sterilant to sterilize your medical device that goes into the patient's body, so for those cases, it will be under the FDA purview. And the questions also mention something about the antiseptics. So antiseptics is a different product from the chemical disinfectants. So chemical disinfectants is used on inanimate surfaces, for example, the clean room surfaces, whereas the antiseptic products is basically applied onto the human tissues, human skins. So it comes into contact with the human skins. So under those circumstances and the applications, so those products will be under FDA. So the about 29% or 30% of your answers is correct. Is basically is B. It depends on the products and the applications. So it's a slightly trick questions, as I say. So next we look at the disinfectant regulations for the vendor. So basically the so EPA approves and registers all the antimicrobial pesticides that are sold in the US. So what this means is that all the vendors and the manufacturers, they will need to basically declare the chemical composition, make sure that the EPA approve their actives, antimicrobial actives used in their chemical disinfectants. To make sure that it is safe for use, they will look at the toxicological data. So vendors will need to submit the safety and the toxicological data to EPA, make sure that it is not toxic or harmful to human or operators who use the products. And also it will basically specify, look at the direction for use, whether you use it to mop the surface, apply on the surface, or you do the fogging. How you're going to use it, what is the use dilution. Is it ready to use, or you need to make with the water to dilute it before you use it. And also the efficacy data to support the label claims. So when you look at the chemical disinfectants, there are a lot of label claims. So all those label claims will need to be supported by the efficacy data. So vendor will need to perform the testing to submit the data for approval by the EPA, so that these label claims can be approved, can appear on the bottles of the chemical disinfectants. So in EPA, the efficacy data is based on AOAC test methods, AOAC international test methods. That specifically states that all the vendors will need to use these methods to perform the efficacy testing to support the label claims. So next we look at briefly on the AOAC international tests. So this method is basically primarily qualitative. It is just a pass and fail test. It is using a ring carriers. Sometimes it's called the penny cylinders. You can see that this is the stainless steel penny cylinders. The pass-fail criteria were different for bacteria, tuberculosis, fungi, and spores. So how they do the testing is that these penny cylinders are firstly sterilized and then submerged in the microorganism suspension. After that, you will just put it into a solution of the test chemical disinfectants for a certain period of time. And then finally you take out and then you put into the put the whole penny cylinder into the growth medium with the neutralizer for incubation. So so basically during the incubation, at the end of the incubation, you will check whether there is a growth or no growth. So there is no enumeration. That means there's no counting. It's just a pass-fail test. So the use dilution test method, there are these few test methods that is commonly used. You can see these are the few methods specifically for different microorganisms. So basically this is the AOAC international test that is performed by the vendor. So next we look at the some of the EPA requirements for the vendors. So there are different requirements for different label claims. They are for sterilant. If it is for sterilant, then you need to have the 60 carriers, each on 2 surfaces. So these 2 surfaces that specify to be porcelain penny cylinders and also the silk suture loops. And on 3 microorganisms, the spores, and also the 2 microorganisms, the spores, and 3 lots, so total of 720 carriers. So as you can see, it's quite a few carriers to be performed, the test. And if you are talking about the disinfectants, it's 60 carriers representing 3 lots against 3 bacteria. So in this case, they have the requirements whereby out of the 60 carriers, at least 59 carriers must not show any growth. So that is the passing criteria. Also, you have the fungicide as well, 10 carriers. So if you have only 10 carriers, then all the carriers will need to show absence of growth. So that is the acceptance criteria. Of course, there are also claims on tuberculosis and also the virus side as well against the virus. So there's no specific requirements on the type of virus to be tested, but most will just test on some of the a common influenza virus and can also be on the HIV virus. So these are the typical requirements for the EPA regulations that the vendors will need to meet in order to support a label claim. So next we look at the an example of the vendor label claims. So when you look at the chemical disinfectants, you will see sometimes bactericidal, fungicidal, or tuberculocidal. So what are the claims? So in this bactericidal, they were mentioned against what microorganisms and passes what kind of tests. In this case, it is AOAC germicidal use dilution test diluted with 400 ppm AOAC hard water. So this one is basically 0.04% hard water, means it consists of calcium carbonate So it's a worst case challenge. And then what is your use dilution? One is, in this case, it is 1:128, 1 ounce per 1 gallon US gallon solution. This is the use dilution in the presence of a 5% organic soil. So typically, soil are also added as a worst case challenge. In this case, it's a 5% organic soil. Contact time 10 minutes and 20 degrees. So these are the test conditions and against what kind of microorganisms. So same for fungicide and tuberculosis as well. So this vendor label information will give you an idea of the efficacy of different types of disinfectants and also even the sporicidal agent. So this will give you an idea of the efficacy, will help you in the selection of the appropriate chemical disinfectants for your clean room cleaning and disinfection program applications. So next, why do end users need to validate the disinfectants? So these chemical disinfectants are basically applied on the non-product contact clean room surfaces. So this is to ensure that the disinfectants is effective in destroying the microorganisms. And also the vendor registration testing does not address the organisms or the surfaces in your clean room environment. As you can see, the AOAC methods performed by the vendor is just performed on the on 1 or 2 surfaces, not representative of your own clean room environment, the surfaces. And also the organisms are all based on the ATCC type of microorganisms. So typically you will need to include your own facilities isolates in your coupon studies program. So that's why end users must need to validate the disinfectants. So you look at the regulations, EU Annex 1, you will need to basically mention that validation studies should demonstrate the suitability and effectiveness of the disinfectants. So this EU Annex 1 is the latest draft 2020. So hopefully this will be approved for next year. So we mentioned that the validation studies will need to be conducted to demonstrate the effectiveness of the disinfectants. Sorry, let me see. Let me do the spotlight first. Okay. So the PICS guideline as well. There's a statement on the effectiveness of disinfectants and the minimum contact time on different surfaces should be validated. So this means that you need to perform disinfectant validation to validate your contact time. Let's say you have a 10 minutes contact time, so make sure that you validate the minimum contact time on the different surfaces in your clean room. And also the FDA guidance for industry 2004. So this will basically also states that the efficacy of the disinfecting agents and procedures should be assessed. So the effectiveness of the disinfectants and procedures should be measured by the ability to ensure that the contaminants are removed from the surface. So this goes to show that you will need to perform the efficacy studies for the chemical disinfectants used in your facilities. And also the some of the guidance documents, USP 1072, disinfectant and antiseptics. So in this case, the selection of suitable disinfectants and the verification of the effectiveness in surface challenge testing is critical. So this also states that you need to perform the efficacy studies. Technical report 70 as well, qualification of a new antimicrobial chemical agent to include both laboratory and in-situ testing. So I will elaborate this a little bit more later. So lab testing means referring to the suspension testing and also the coupon testing. And in-situ testing is basically when you're using the disinfectant in your clean room, you will need to perform some kind of effectiveness check. So I will elaborate on this a little bit more later on. So next one, draft 2020.
फाइल मेरे ही पास है। हाँ, इसमें वो क्वेश्चनर असेसमेंट तो नहीं है, वो प्रिंट निकालना पड़ेगा मेरे ख्याल से। नहीं, जो अपना क्वेश्चनर असेसमेंट रहता है ना।
So this is the Annex 1 draft 2020. So if you see this the draft, there's a statement that says that more than one type of disinfecting agent should be employed to ensure that they have different modes of action. So I explained the different modes of action in the next slide, and their combined usage is effective against all bacteria and fungi. So different modes is basically meaning the different ways of inactivating or killing of the microorganisms. There are many ways of inactivation of microorganisms. So this is basically referring to that. And 4.37 states suitability and effectiveness of disinfectants should be demonstrated in the manners in which they are used in the clean room. So this is in the Annex 1 draft 2020. So this is a simplified diagram of a bacterial cell. So you can see that there are a few components. You have the cell wall. So cell wall is peptidoglycan, made of peptidoglycan. Basically, this is to give the shape of the bacterial cell. And they also have the membrane as well. The membrane is basically act as a permeability barrier to control the movement of the molecules into the cell. And you have the ribosomes. Ribosome is basically to make the proteins for the cell. And you also have the cytoplasm, is basically a solution that fills up the cell, the inner side of the cell. So these are the some of the components of the microorganisms. And if you use chemical disinfectants, phenols, they'll act on the cell wall to kill the microorganisms. If you have the hydrogen peroxide, of course, it will act on the ribosomes. And the quartz as well, quaternary ammonium compounds, it will basically cause the cell contents and also the coagulation of the contents. If you have the alcohols, you can add on the general membrane permeability. So these are the different mode of action when you have a different chemical disinfectants. So these give you an idea of there are many ways of inactivating the bacterial cell depending on the type of the chemical disinfectants that you're using. So next is the disinfectant validation components, the major components. So the first one is the in vitro testing. So in vitro testing is basically the lab scale studies. In vitro means in the lab. So it's a lab scale studies. So it basically depends, consists of two parts. First one is the suspension testing, also called the time kill study. So this is the, as the name suggests, basically you introduce the microorganisms into a test tube of the test disinfectants, suspension testing. So this is basically typically used as a screening tool to see what are the different efficacy of the chemical disinfectants, the screening tool to compare the efficacy. So this can compare like a time required to achieve an acceptable log reduction, the contact time as well. But this test does not take into account the different substrates. So it is not a simulation of the actual cleanroom conditions, but rather it is used as a screening tool for you to quickly know the efficacy of the different disinfectants. And also this can also be used to basically determine the approximate contact time required for your particular disinfectants. For example, if you want to know this quad disinfectants, what is the contact time required to inactivate a fungal spores. So you can perform this quickly to determine the approximate contact time required. So this is the suspension testing. So this is not compulsory, but it's a good, useful tool to perform to get you more information. Of course, I know there are some companies that have the internal procedures, requirements that you need to perform suspension testing. But from the regular point of view, I mean, there's no requirement. So next is the most important one is the carrier testing, also called the coupon testing. So this is basically to evaluate the disinfectant efficacy under simulated actual conditions. So as the name suggests, you will need to use the different clean room substrates in the lab, and then also include the in-house isolates, your microorganisms found in your clean room under the specified temperature and also the contact time to simulate as much as possible the clean room conditions. So this is basically more accurate to determine the efficacy of your chemical disinfectants. So after you pass your coupon studies, and then you can start to use your chemical disinfectants in your clean room, actual clean room, to perform the cleaning and disinfection. So the next stage will be the in-situ testing. So once you start to use it in a clean room, then you will need to demonstrate the effectiveness of your product applications in the real world, because there are still some slight differences between the lab and your actual clean room conditions. So basically, this will basically involve some EM monitoring data under the worst case events to check the before and after application of the EM data. Make sure that there's a decrease in the bioburden level after the application. So I will talk a little bit more on this in-situ testing later on in the presentation. So these two are the main components of the efficacy studies. So of course, if you follow the European standards, so European standards, they are classified into 3 phases. So slightly different. Phase 1 is so-called the suspension test. So this is a very basic suspension test. You just determine the contact time for or to see your chemical disinfectants, whether is it effective against what kind of microorganisms. A very basic test without any challenge. So this is a basic suspension test. And then you have the phase 2 quantitative test. Phase 2 step 1. So phase 2 step 1 is the suspension test. So this one is basically slightly more detailed because it involves the clean and soil conditions. For bactericidal, fungicidal, sporicidal, you can look up the EN standards for the respective test requirements for the suspension test. And then after that, you have the phase 2 step 2, which is the hard surface carrier test. So commonly used is the EN standard 13697. So this is the hard surface test, which is the so-called coupon studies. So after you pass your coupon studies, then you move on to phase 3, which is the field trial. So this is basically the in-situ studies. So it's a slight difference, but the main components are similar, basically. So next we look at some of the warning letters. So warning letters is basically, in this case, disinfectant efficacy studies was not conducted in the manner in which the disinfectants are used. For example, I mean, if your contact time in the studies is 10 minutes and when you apply the disinfectant, it's only 5 minutes contact time. So that is basically an observation. In this case also, the surfaces near in the clean room, especially close to the critical areas, the surfaces are not included in the coupon studies. So that is an observation as well. So basically the FDA warning letters, these are some of the common observations. That means did not perform the efficacy studies for the chemical disinfectant use, did not include the representative surfaces in the aseptic processing area. For example, the floors, the walls, and the work surfaces that are close to the critical areas. And also not including the environmental isolates in the study, only use ATCC. No data to support the contact time as well. So if you specify 10 minutes contact time in your cleaning procedures, you need to have the efficacy studies documents to support the contact time specified in your cleaning procedures. So next we look at some of the common coupon studies standards that are used to conduct the coupon studies. So before that, this is poll question number 2. So Christina.
Yeah, okay, coming up.
So this question is which testing method do you use? ASTM, EN is European methods basically, or no preference?
So we give it maybe a minute. We have 75% have answered. 10 more seconds, and then we end. Okay.
Okay, so that's interesting. Split quite equally among the 3. Okay. Yeah, I mean, okay. Let me see. Okay, next I will go through briefly the 2 methods that are commonly used, the EN methods and also the ASTM methods. So these are the disinfectant qualification guidance documents that you should be familiar with before you perform the efficacy studies. So ESP 1072, disinfectants and antiseptics. So basically this mentioned about the use dilution test, surface challenge test. So this not that detailed in this guidance. They also mentioned about the challenge microorganisms that are commonly used and the log reduction criteria as well. So what are the log reduction criteria? So it's a very useful reference for you to conduct the efficacy studies. And also if you look at the PDA Technical Report 70, they also mention about the details of the suspension studies, carrier surface studies, and also the in-situ field studies. So these are good information to look at. So ASTM methods is basically the international methods. This is quite commonly used as well for disinfectant efficacy studies. So if you look at the ASTM E2614, so this is the standard guide for evaluation of clean room disinfectants. So in this guide, they mention quite details in the in vitro studies requirements, the in situ tests, and also the EM training as well. They also refer you to the relevant guidance document number as well for performing the efficacy studies. So these are very useful documents to look at. And the next 2 is basically the main documents for performing the time Q studies, the suspension studies, which is the E2315. So this will tell you how to perform the time Q studies based on the ASTM methods. Next one is the commonly used for the coupon studies is E2197. So in this guidance documents, all the details on how to perform the coupon studies are written inside there. So it's a very useful guide for you to perform your efficacy studies. So for the EN methods, these are the common methods used. Of course, the suspension tests. So the suspension tests, these are phase 2, step 1. So these are all the bactericidal, fungicidal, and sporicidal suspension tests. So if you want to perform the coupon studies, then you will need to use the EN 13697. So this is the quantitative non-porous surface test. So this is the main test for the European methods. So these two methods are basically okay. I mean, it's depending on your preference. So EN 13697. So there is some revisions 2015. Some of the key revisions include on the soiling conditions for Pseudomonas aeruginosa, they changed from bovine albumin to skim milk under clean conditions. And also there's a requirement on the evaluation for 75% mature spiny spores for the Aspergillus brasiliensis prior to testing. So this is, they consider the spiny spores as the worst case. So there's a requirement to verify this before you perform the spore testing. And then also the methods verification criteria is modified, include the neutralization toxicity. And lastly is the calculation of the weighted mean of the counts. So these are the some of the revision in 2015. I just got to know that I think last year they also just updated as well to remove the skim milk. So there's a latest revision as well on this 13697. So this is the diagram of the spiny spores. So if you look at the microscope, you can see that this is not so clear, but you can see the spikes. You can see the spikes here basically. So this is basically to make sure that it's spiny spores, at least 75%, to pose as the worst case challenge in the efficacy studies. So if you look at the comparison between these two methods, so ASTM E2197 and 13697, so there are some differences in each stage of the testing. So if you look at the description, so description is basically, this is the flow of the testing. So of course, the stainless steel, the carriers, your clean room substrates, size is different. So ASTM is 1 cm, then EN is 2 cm. Then you have the inoculation as well. And then your inoculation means you put the microorganisms on the disc. And then after that, you dry it, put the test disinfectants on the dry inoculum. After the contact time, let's say 10 minutes, after 10 minutes, you neutralize it with the neutralization methods. And then you perform the recovery. So recovery of the microorganisms from the disc. So there are some differences in the recovery between these two methods. So ASTM, they use the vortex methods. EN 13697, they use the glass beads. So they use the glass beads to dislodge any residual microorganisms from the surface. So there's major differences in the recovery methods. So after recovery, of course, you do the calculation. So these are the, just give you an idea of some of the differences between these two methods. Yeah, it's a size. So EN 13697, you need to have at least 75% spiny spores versus the smooth spores. So smooth spores is not the worst case. So you need to have at least 75% spiny spores. And then just use glass beads to recover the microorganisms. So these are just some of the pictures using glass beads to recover the microorganisms from the disc. So this is a 13697, 2 cm disc. You can see the inoculum, the microorganism inoculum. And after dry, then you apply the test disinfectants on the inoculum. ASTM E2197, this is smaller, so you can see the size smaller. So this is also inoculum, and then after drying, then you apply the test products on the disc. So if you look at the USP 1072, so USP 1072 that does not provide specific guidance, very detailed guidance on the recovery methods. And you also mentioned the larger coupons. I think it's 2 inch by 2 inch. So you can see that if you use 2 inch by 2 inch, the coupon is quite large compared to your inoculum, the volume of the inoculum. So when you have a large coupons, you may have some issues in the recovery of the microorganisms. So typically, there's no need to use such a big coupons. You can just use the size specified in the ASTM or the AN methods, which is a 1 cm or 2 cm disc. That's good enough. So next, we look at some of the points to consider. Before that is poll question number 3, Christina.
It's coming up.
Okay. So this question is, how do you carry out your DET, disinfectant efficacy tests? Is it in-house by your own or outsourced to third-party lab or not at all?
So we give it a minute again. Another 15 seconds.
Okay.
Okay.
And so majority is in-house. Okay, that's good. Okay. So, so before you perform the efficacy studies, so what do you need to know? So typically, when you have a vendor, I mean chemical disinfectant vendors, they will provide you with all the technical data on the disinfectants, use and preparation methods. So how to use, how to prepare the disinfectants, safety data sheets, substrates compatibility as well, whether the disinfectant is compatible with your clean room substrates. Because if not, sometimes, especially the sporicidal agent, a strong oxidizer, can cause compatibility issues with your clean room substrates. And also the stability, that means the closed container stabilities, open container stabilities, and for those use dilution. So use dilution stability as well after you mix the chemical disinfectants with the correct concentration, and then how long you can hold before you need to use it. So that is the use dilution stability. So this data, I mean, typically vendors can give you all this stability data. And also the microbial efficacy. So typically it's from the product registration based on AOAC. Of course, there are some disinfectant supplier can also provide you with some of the coupon studies as well. Of course, these are the vendor information. So what is most important is you need to know the performance of the chemical disinfectants in your own facilities based on the preparation procedures, how you prepare the disinfectants, application methods, how do you apply, whether you do fogging or just apply mopping on the surface or spraying, and also the actual clean room surfaces, contact time, and using your in-house isolates. So you will need to know the performance under all these conditions. So before you get into the efficacy studies, so you need to understand basically the environmental conditions in your clean room, whether grade A, B, C, D areas, the air change rate. So this can affect the contact time and also the microorganisms. What are the microorganisms that you plan to be included in the studies? So microorganisms should be broad spectrum, yeah. So you need to decide and understand the microorganism resistance as well to the hierarchy. So whether some microorganisms are harder to kill than others. So you need to have some basic understanding on the microorganisms resistance. and also the antimicrobial products. So there are many different kind of antimicrobial products in the market. So you need to understand, choose the appropriate antimicrobial products to be part of the cleaning and disinfection programs for your clean room to control the bioburden levels in your clean room. And also the application procedures, whether just wiping, mopping, spraying, or fogging. And of course, the surfaces are very important. So this will play a big part, very important, will affect the efficacy of the chemical disinfectants. So these are the few areas that you need to really think about before you get into the your disinfectant efficacy studies. So next, let's look at the clean room surfaces. So clean room has a lot of different kind of surfaces. You have a stainless steel 304, 316. So most furniture, clean room furniture is 304 stainless steel. Of course, some product equipment is 316L grades. Of course, you have the glass, plastic vinyls for curtains. You have a polycarbonate insulation or plexiglass for the shield. Plexiglass. And also the epoxy coated gypsum for the walls and the ceilings, terrazzo, tiles, epoxy coated floorings. So you have different kind of materials. So you need to basically include the representative materials in the coupon studies. Of course, sometimes it's not possible to include every materials. You will need to perform some kind of risk assessment because, for example, the surface, although a surface can look smooth, so this is a gypsum surface. If you look under the scanning electron microscope, you can see that the surface actually has different topography, have the valleys and the up and downs. So this can pose a challenge to the disinfection process. So it's very important to include the most representative surfaces from your clean room. So this is just an example to show you the effects of different surfaces. So for example, Staphylococcus aureus, if you perform the coupon studies on stainless steel, you can have more than 5.2 log reduction on a vinyl surface, 3.9. So this goes to show us that different surfaces have a significant impact on the efficacy depending on the surface conditions and the material as well. So this is basically an idea for you to choose the most representative surfaces, because as you know, clean room has a lot of surfaces. It's impossible to include all the surfaces because the more surfaces you use, the more tests you will need to perform. So basically you need to perform some kind of a risk assessment based on the matrix approach. You can based on the surface roughness. Typically, the rougher the surface, the more difficult it is to achieve the required efficacy. And also the proportion of surface area in the clean room. So large surface area like floors, walls, those will need to be included definitely. Proportion of surface area. Criticality of surface, proximity to your critical process. So those surfaces very close to where your product is exposed to the environment. So you may want to consider that as well. The frequency of touch point, the touch point by operators, typically those are the most dirty part of the areas. So frequency of the touch points. And also you can consider the similarity in composition. Like you can group the substrates together, same group of same type of materials. You can choose the worst case based on some assessment. So these are some ideas that you can use to basically choose the representative surfaces based on the risk. So next is the antimicrobial products. So you need to understand what are the antimicrobial products available and what are their efficacy. So under the EPA classification, so sanitizer is typically the IPA, alcohol 70% IPA or 70% ethanol. And disinfectant can be quaternary ammonium compounds or phenolics. Or for sporicide or sarin, It can be a strong oxidizer like sodium hypochlorite, or vaporized hydrogen peroxide, or hydrogen peroxide and peracetic acid blend. So these are basically some of the very strong oxidizing agent, which can kill the bacteria and fungus spores as well. So you need to understand each group of these chemical disinfectants and their efficacy. So sanitizer is basically used on a daily basis, not very effective against the spores. Same goes for disinfectant as well. You need to have the sporicidal agent to basically address the bacterial spores. So in the disinfectant efficacy studies, if you test sanitizer or disinfectants against the bacterial spores, likely you will get a failed results. So understand the efficacy of your chemical disinfectants and their intended use as well before you decide what to test against what microorganisms. So this is the microorganism resistance hierarchy. So this one has been shown before during presentation, during the other presentations. So this is basically shows you the resistance. So at the bottom of the table is basically easily killed microorganisms. As you go up the table, become more resistant. So for bacterial spores, is quite resistant. So for sporicidal agent, can address most of the microorganisms, including the bacterial spores. So sporicidal agent, for example, the hydrogen peroxide, vaporized hydrogen peroxide, peracetic and hydrogen peroxide blend, or sodium hypochlorite. So those are very effective against the spores. And if you have a disinfectants, phenols or the quartz, it can be up to microbacteria here only. So it's not effective, not very effective against the spores. So that's why you don't test the disinfectants against the bacillus spores. And if you have the sanitizer, is can be until gram negative. So you will need to know the efficacy before you choose which organisms to test for the sanitizers. So even for bacterial spores, there are different level of resistance as well. So Bacillus cereus or sphaericus is more resistant than subtilis. So there are some slight differences in the resistance as well. So this is just for your information to know that when you choose the microorganism to test for your chemical disinfectants, make sure that you choose the appropriate organism to test. So bacterial spores, why is it so hard to kill? So this is the spore structure. So you can see that bacterial spores under adverse environmental condition, they will change into a spore form. You can see that there's a thick exosporium and a spore coat. So this is basically to protect the bacterial cell, spore cell. So only the strong oxidizing agent or some of the strong disinfectants can kill these bacterial spores. So normal disinfectants and the sanitizer like alcohols will not be effective. So in fact, the spores can survive for a long period of time in the alcohols. So this is just a scanning electron microscope on the bacterial spores. You can see the spore structure is well protected. So next is the environmental conditions. You need to consider the room classifications, A change rate, of course, grade A areas, AB areas, high A change rate. You will need to consider the contact time as well. Sometimes not easy to achieve the contact time of 10 minutes. And also the humidity and temperature as well. So typically, chemical disinfectant are applied at room temperature. So if you have a low temperature, you will need to increase the contact time, and also the application procedures, wiping, mopping, or defogging. So the efficacy studies variables, whether you do in-house or external lab, you need to consider the number of microorganisms tested, so and the type of the microorganisms. Of course, typically 6 to 10 microorganisms, including your in-house isolates, typically are used. Contact time typically is 10 minutes. Substrates, surfaces tested, include your clean room substrates, and the disinfectant and the sporicidal agent. So what are the sanitizer, disinfectants, and sporicides to be tested? So this is just examples on the number of tests. So if you have 3 microorganisms, 2 substrates, and 1 sanitizer, 2 disinfectants, and 1 sporicide. So the total number of tests is 3 times 2 times 4 is 24. So each test is performed in triplicate, so times 3 as well. So as you can see, if you increase the number of microorganisms and the clean room substrates, you will increase the number of tests. So, so you need to take this into consideration. So other considerations, age of the product tested. So for example, the use dilution. So when you make the use dilution, can have the, sometimes can have 1 day or 3 days or 5 days. So you can include that as well in the coupon studies. You consider whether you want to do suspension studies. Of course, coupon studies is most important. Temperature as well. If you have a cold room, then you will need to conduct the studies at low temperature. So other conditions, soil or clean, water quality as well. So typically for clean room, we perform under the clean conditions, unless you have specific process that is very dirty. Yeah, so typically you coupon study is performed under the clean conditions. And also you need to consider the efficacy requirements. So what are the acceptance criteria for your coupon studies? So if you look at the microbial reduction guidelines under USP 1072, so vegetative bacteria more than 3 log, bacterial spores is 2 log. There's no guidance on the yeast and the mold for 1072. So PDA Technical Report 70 is all 1. EN 13697 for vegetative bacteria is 4 log. Yeast and mold is 3 log. So typically for the acceptance criteria, bacteria we take 3 log. Yeast is 3 log. Fungal spores can be 2 log, and the bacterial spores and 2 log as well. So typically those are the combination on the acceptance criteria used for the coupon studies. So when you select the microorganism selection, must be broad spectrum, most frequently occurring in the environment, high levels in the environment, and also the demonstrated decontamination difficulty at the facilities or the worst case. So if you are new facilities, of course, you can use the ATCC strain challenge microorganisms. But if down the road you have your own environmental isolates, you may want to consider doing that as well. So the key is include some of the environmental isolates in your studies. So this is the typically the broad spectrum microorganisms that you will need to include, panel of 6 to 10 microorganisms from gram-negative bacteria, Pseudomonas, gram-positive, non-spore forming, Coccus, Staphylococcus, Staph, Corynebacterium species, mold as well, Aspergillus brasiliensis. These are the most challenging mold, Penicillium as well, and the gram-positive spore formers. So like Bacillus cereus, Bacillus subtilis, sphericus. So typically the Bacillus spore formers is done for the sporicidal agent only. Disinfectants, you can include the mold as well, gram-positive, gram-negative, and the mold. So so when you perform the coupon studies, of course, there's a neutralization methods. So there are 3 methods for neutralization. So most common one is the chemical neutralization of the active. You use a neutralizer. Of course, the other one is the dilution. So generally not effective alone for dilution unless it's alcohol. So typically it's used chemical neutralization and also the filtration plus rinsing. So this is to separate the active from the organisms. So when you use the chemical neutralizer, you need to perform the neutralizer validation as well. Make sure that it is not toxic to the microorganisms. when you use the chemical neutralizer. So typically the validation is required. So these are the validation done for neutralizing agent. So you need to check the efficacy. So make sure that it is able to neutralize the chemical agent. So you do this by add the neutralizing agent to the test disinfectant, and then you introduce the microorganism. Make sure you can recover at least 70% of the microorganisms compared to the positive control. Same for non-toxicity as well. Make sure that the neutralizer is not toxic to the microorganism. So this is basically to introduce the microorganisms into the neutralizing agent, and then you recover it at least 70% of the neutralizing, the microorganisms compared to the positive control. So these are just some of the examples of neutralizers from technical report 70. Yeah, this is the low temperature. So under low temperature, typically you will need to increase the contact time of the chemical disinfectants, especially 2 to 8 degrees, increase by around 4 to 5 times of the contact time at ambient temperature. So these are just some of the examples of the efficacy time Q studies for sporicidal agent against the Bacillus subtilis and the Aspergillus brasiliensis. So this is the hard surface test results. So to show you this is the hard surface test using the hydrogen peroxide and peracetic acid blend on the Bacillus subtilis. So you can see the different substrates here. So at 1 minute is not effective. You need to have at least 5 minutes contact time in order to achieve at least a 2-log reduction. So this is basically shows you the efficacy can vary across different kind of substrates, clean room substrates. So next, pool question number 4, Christina.
Yep. Okay. Okay.
So which microorganisms do you select for your disinfectant efficacy studies? Is it ATCC only, environmental isolates only, or a combination of ATCC and environmental isolates?
Hi, Richard. We have 15 minutes to go.
Okay.
20 minutes, sorry.
Yeah, almost done, almost.
Okay, so I'm going to end the poll. I think it's quite clear.
That's good. So most of you will have a combination of ATCC and the environmental isolates. Yeah, that's the that's the answer. That's good. Okay, thanks. Okay, next is the last few slides on overcoming common challenges. So typically when you perform the efficacy studies, you will have some kind of issues encountered. So these are some of the common causes. So testing the biocide against the inappropriate microbes. That means you test the disinfectants against the bacillus spores, or insufficient contact time for bacterial spores. So typically for bacterial spores, you need at least 10 minutes. If you have 5 minutes, certain surfaces may not get you a pass results. And also the incorrect preparation of used dilution. So this will affect the concentration. So inoculum, poor viability of inoculum suspensions, and you prepare the fungal and bacterial spores suspension incorrectly. So especially for fungal spores, you will need to get rid of the mycelia fragments and also the germinating spores. So just to make sure that you test the spore states. And the neutralization as well, inadequate neutralization, or your neutralizer is toxic to the microorganisms. So for the surfaces, so sometimes you have porous surface or damaged surface. Coupons cannot be steam sterilized, or uneven surface on the substrates. So this can affect the efficacy of the test result as well. And also the recovery, so lethality after drying. So if you have the Pseudomonas aeruginosa, so this drying will affect the viability of these microorganisms. So take note when you are drying these microorganisms during the studies. Setting high log reduction targets. So you set a 4 log reduction for bacterial spores, likely you will get a failed results. And also the recovery methods not validated. So recovery methods for microorganisms, you can follow the USP 1227 for the recovery methods. So these are the examples of the fungus spores. You can see that the hyphae, error, and mycelia as well. So this will need to be removed. You need the spiny spores for the testing. So surface coupon issues. So this is the big issue. Sometimes the surface type and the conditions will affect the efficacy significantly. So you need to basically prepare the surface before you test. So some can be autoclave, but some will need to use the chemical sporicide agent to basically to treat the surface before the testing. So, and also some surfaces can pose a challenge, like for example, the peeling after sterilization or the surface tension issues. Surface tension means you cannot have a good coverage of the disinfectants on the surface. So if you look at the surface using a scanning electron microscope, you can see sometimes if it's a damaged surface, a lot of crevices, then you will need to basically, this will cause the failures of your test results. Older or damaged surfaces can be more challenging. Typically, the glass and stainless steel is the least challenging because they are quite smooth surface. So these are examples on the issues: peeling, surface tension issues on the surface, surface roughness. So next is the in-situ testing. So after you pass your coupon testing, so you use your chemical disinfectant in your clean room. So under 1072, that says that you need to basically have a comparison on the isolations and the number of microorganisms isolated before and after implementation of a new disinfectants. And if you look at the FDA 2004 guidance documents, the effectiveness of this sanitization procedures can be demonstrated by obtaining samples before and after the sanitization. So typically for in-situ testing, why do we need to do that? Because the actual clean room conditions can be different from coupon studies. The microorganisms, numbers, the types, and the physiological states in the clean room can be different. Surface condition as well, the aging, the roughness, degree of abrasion, soiling. There's also some slight variation in the environmental conditions in your clean room compared to your lab and the cleaning technique as well. So having said that, if you have passing result for your coupon studies, there's a high confidence that it will work in your clean room. And with your unless you have the follow the best practices in contamination control as well. Of course, if you pass your coupon studies but your contamination control procedures is poor, for example, there's no robust sanitization procedures for transferring of materials into the clean room, you will contaminate your clean room as well, even you have a passing result on your coupon studies. So these two work hand in hand, but the passing result for the coupon studies will give you a high confidence that it will work in the actual clean room environment. So in-situ protocols basically is use actual cleaning procedures. Of course, this will need to take into account the worst case conditions before after cleaning during routine operation. For new clean room as well, if you shut down your clean room, want to start up again, so there's a sequence of cleaning. So those are worst case events in which you can collect the EM data and shows a decrease in the bioburden levels after each cleaning and disinfection. So those are very good data to demonstrate the effectiveness of your chemical disinfectants use. So basically is to compare the environmental data before and after the procedures. So requalification, so you need to review annually to assess the risk, whether any changes have occurred, significant changes in terms of the disinfectant use, or if new bioburden appears at high levels in your clean room. If you introduce new disinfectants or you have new surfaces are added in your clean rooms, so this will typically have to validate again using the coupon studies to ensure that they are effective. And also re-evaluate every 5 to 7 years to determine if any repeat testing is required due to the testing deficiencies, because sometimes some of the test methods or test standards, they update, change the standards. So you will need to basically review and re-evaluate whether you still meet those requirements. So with that, I come to the end of this presentation on the points to consider for the disinfectant efficacy studies, to get an idea of the important points to consider before you get into the efficacy studies.
Thank you, Richard. And thank you also for those people who have posted questions, and to Leo, who has replied to some of them already. Does anyone want to unmute themselves and ask any more questions?
Hey, Richard, it's Thomas here from TSC. Just if you could go back to that famous table that you showed with the resistance, maybe just a bit of a layman's person to start off here. I was wondering whether there's any studies or yet any research done where various coronaviruses would be on that chart, and then what would be suitable sanitizers or disinfectants for this type of virus. Yes, this one, thank you.
Yeah, so typically the viruses are not difficult to kill. You can see that the viruses are divided into two types. One is the non-enveloped virus. So the other one is the enveloped viruses, which are the HIV, hepatitis B virus. If you have a non-enveloped virus, it's slightly more difficult to kill because they do not have the lipids, which is easily destroyed. So this one is under the rotaviruses and adenoviruses. So basically, for coronavirus is easy to kill. You just use the sanitizer. Alcohol is good enough to kill all these two groups of viruses. Yeah.
Okay, thank you.
Welcome. Any more questions? So of course the questions we can also address later. I mean, if it's in the chat box.
Yeah, so there's a few in the chat box I can see.
Let me see.
From David. Can you see it?
Let me see. Feel free to pose any questions. The questions regarding tests in the cold room. Yeah, okay. There's one question on the test in the cold room. Contact time should be longer in that place. However, I guess disinfectant solution must be ice and solidify for a longer time in a cold room. Yes, the contact time, I mean, the coupon studies, you can, for 2 to 8 degrees, I mean, you can basically simulate in the coupon studies. There's a way to simulate that. So definitely you will need to have a longer contact time. Yeah. So depending on the temperature, so most of the cold room is 2 to 8 degrees. So it shouldn't be a problem to simulate in the lab for this temperature.
Hi, Richard. Neo has answered some of these questions now.
Okay.
But if you go right down to the bottom, Richard has submitted, David has submitted a question. in the context
David?
of, yes.
Hi, Richard. Good evening.
Okay.
Yeah, thanks for your presentation. Yeah, I have a few questions, and these are quite probably lengthy. That's why I wanted to post these here while you were presenting. So I appreciate that you made the time to share with us in the ISP network about your experience with cleaning disinfectants. So the context of my queries is as follows. Prior to performing environmental monitoring performance qualification for new startup facilities, it is common in best industry practice to do a baseline count study to gather data on potential microorganisms, flora that are present within the clean rooms. So my questions are follows. Are you able to recommend any best practices for performing those baseline count studies and EMPQ? And second part of my question is about international regulations. I'm just wondering if you have experience with minimum durations, time periods for performing baseline count studies and the EMPQs in order to ensure the GMP release of these clean rooms. So thank you, I appreciate your time.
Okay. Yeah, so absolutely it's necessary to have the baseline count. So basically for new facilities, of course, after you have construction completed, the clean room completed. So typically there's cleaning procedures in place basically to turn the clean room into to meet the acceptance criteria in terms of viable and non-viable particulate counts, so that the production can begin. So basically during that period of reinstatement of the clean rooms, there's a series of cleaning. So of course the first one is basically you need to have a baseline count monitoring. So you collect the samples on the baseline before any cleaning. And so there's a time 0. So of course you perform the air monitoring, surface, contact plates, setup plates, whatever. So that will be a very useful information on your baseline. And then you perform the cleaning and disinfection. So typically this can be 3 to 4 times or 5 times. So there's no requirement on how many times, but typically it's at least between 3 to 5 times of cleaning. So after each cleaning using the disinfectants. So for example, you use disinfectants to clean for the first 3 days, and then after that, you use the sporicide agent. So after each cleaning, you will monitor basically the count again. So typically you will need to have a very good, it's basically the EM monitoring is based on the ISO standards, basically the number of locations and the risk assessment as well, based on your assessment of your clean room. Of course, the high traffic areas, high touch point. So all those points you will need to determine basically in your EM monitoring program. Of course, you will need to collect those data after each cleaning to show that there's a reduction in the bioburden levels. So those baseline count is essential basically to make sure that you know what is the typical flora found in your clean room and the counts at the baseline and how effective is your cleaning to basically turn your clean room into turn over to the production so that they can start the production activities. Yeah, so basically this is my understanding for greenfield facilities. Yeah.
Great. Thank you so much, Richard.
Yeah. Okay.
We have time for one last question. If anyone has a burning query.
Yes, I have. Hi.
Yes. Hi.
Your son here, Richard. Okay, I want to ask about in the market, there is one very quick way to determine the cleanliness of a surface using the ATP, measuring ATP. Is that
ATP,
allowed to use that device to to do the checking of the clean surface? Thank you.
That will fall under the rapid micro methods. Yeah, the ATP. Of course, in the market, there are some rapid micro methods. So I'm not sure exactly that includes the ATP. It could be, but I'm not exactly sure on that methods right now. But typically, I mean, those news methods, you will need to have extensive validation to correlate with your typical EM monitoring methods. Yeah.
Okay, thank you.
Okay.
Okay, well, thank you very much, Richard, and to everyone for attending. If there are no other questions, then we'd like to finish off the session, unless there are any other comments. The approved slide deck will be sent by link to you after this session, and we do really appreciate any feedback that you could give us with regards to how we can improve, and also to give feedback for the speakers. So thank you everybody for joining this session. It is now 6:30, and wish you a very good evening. Thank you.
Thank you. Thanks.
Thank you, Richard.
Thank you.
Thanks and goodbye.
Thank you, Richard.
Thank you.
Thank you.
If anyone has any last minute wants to ask Richard anything, he's still on the line, so you can fire ahead. You can see the comments, Richard.
Let's see.
On the chat, people are saying thank you, and
Let's see.
yeah, lots of thank yous. It's a whole running thing. You can start from the bottom and work your way up.
Oh, okay.
Yeah. Okay. So we have Liang Tai. I thank you for sending your question. If you have any other follow-up questions, I think Neo or Richard will be able to contact you after this session as well.
No, not at this moment. I can easily reach out. No problem. Thank you.
Okay. Thank you very much.
Okay. Thank you. Thank you.
All right. So
should I close the meeting?
Yeah, I think there's only 2 others apart from the 3 of us. Is it?
Oh, there's a couple. Yeah. We have 17.
Yeah, okay, if you want to close the meeting. Thank you everyone for joining. Thanks again, Richard.
Okay, thank you. Thank you.
Have
Thanks.
a good evening. Bye.
Bye.
Bye.